Hello friends, how are you? I hope you all are good. In previous lecture only we saw sodium chloride. So one of the important salts. Okay. So in that sodium chloride, now we have to discuss large production of that sodium chloride. Okay. So how we can observe this large production of sodium chloride. So basically whatever your sodium chloride, okay, it will occur in nature in the form of two main states. So that which one that two main states. So see here, whatever your salts present in nature, it dissolve form where in sea water, dissolve form in sea water. And second how it will occur as a rock salt, as a rock salt in solid form, as a rock salt in solid form. Understood? So basically these two main states where our sodium chloride large scale production. Okay, so first we will discuss here whatever our common salt from seawater. Okay, so say here common salt in sea water. Okay, common salt in sea water. So how it will see here, whatever your sea water. Okay, so sea water contain dissolved salts which obtain after evaporation in shallow pools. So what is the meaning of this shallow pools? Means what? See here, wherever whatever your water, okay, or we can say least water. So at that whatever there is a region there least water content. So at that condition we have to whatever evaporation we have to do. Understood? So whatever after this you will get what impure salt you will get. Okay, impure your NaCl you will get. So we have to again whatever this salt it's purified and iodized by adding iodine before use. Okay, we have to iodize. So as you know, wherever now you are also watching on TV iodized salt. Okay, so how it will iodize? By adding iodine. Okay, then after we can use that iodized salt. Okay, so it is one of the most important. Okay, so you must know here shallow pools means what? What is it is a region where least water content. Okay, so second as you know here what common salt from common salts from underground underground deposits. Common salt from underground deposits. So how can underground deposits, how it will occur your NaCl in the form of rock salt. Okay, rock salt. So which one, whatever that salt, it first in brown in color. So why it is brown in color? Because of various impurities are present in that. Okay, so now we will discuss uses of NaCl. So say here uses of NaCl. So very much important uses of NaCl. Okay, so see first use here as a raw material for making number of chemicals. As a raw material for making number of chemicals. So that number of chemicals like, so say which number of chemicals? NaOH, okay, then your Na2CO3, then NaHCO3. Understood? So these are what uses. So second use we will discuss here. Second use. So as you know, in cooking food, your NaCl is used. Okay, and as a preservative, third word beta, as a preservative, whatever our NaCl we use in pickles. Okay, next also we can as a in manufacturing of soap, where beta fourth we can write here in manufacture of soap. So like that, so many uses of your NaCl. Understood? So see here, we will discuss how, let us see how NaCl we can use as a raw material for various chemicals. Okay, one of the most important. Okay, how your NaCl used as a raw material for where, for various chemicals. So first here we have to write here reactions of that NaCl. So see here how we can write NaCl aqueous plus H2O liquid. So after, if you done electrolysis on your this NaClH2O, so basically NaCl and this H2O, what we call this as a brine solution. What? Brine solution. NaCl in aqueous. Okay, we call it as a what? Brine solution. So after, what will happen here? So as you know, your Na plus and how your H2 will break H plus and OH minus ion. Okay, so see here, NaOH you will get beta, plus what will get? H2 gaseous plus what beta? Cl2 gaseous. Okay, H2 gaseous plus Cl2 gaseous. Understood? So here what you will get mainly caustic soda. Caustic soda you will get. Okay, so during electrolysis, what will happen here? So what in during electrolysis, your chlorine gas is produced at the anode. Okay, so one of the most important thing here during electrolysis, okay, chlorine gas, chlorine gas is produced at the anode, that is your positively charged, okay, anode positively charged, okay, while say while while hydrogen gas, yes beta, hydrogen gas is produced where? At the cathode. So beta, cathode is what? Yes, negatively charged. Okay, so as you know, hydrogen is plus, so they will attract on your cathode, that is negatively charged. Understood? And very much important, add your sodium hydroxide solution and sodium hydroxide, say here, and sodium hydroxide, that is NaOH aqueous solution, sodium hydroxide solution is produced near where beta? Near cathode. Near cathode. So why here question will arise, why your sodium hydroxide is produced near the cathode? Because as we discussed, your H plus hydrogen, that hydrogen it will produce near the where? Cathode, that is negatively charged. And among now Na plus and OH minus, Na plus is your what? Highly reactive. So obviously where it will go? Near the cathode, that is negatively charged. Okay, understood? So it is one of the most important reason. Okay, or we can also conclude this. Okay, whatever conclusion of this, then why your NaOH is produced near cathode? Their SRP value. So SRP value is what beta? It is in 11th standard also, standard reduction potential. Okay, on the base of their values. Okay, also we can consider. Understood? So see, this process, whatever this process of electrolysis of NaCl, okay, this overall process of electrolysis of what? NaCl aqueous, or we can say what? Brine solution. We call it as a what? Chlor-alkali process. What we call? Chlor-alkali process. So say here, chlor-alkali process. So beta, why it is chlor-alkali? Chlor means what? Yes, here we got chlorine. Chlor means what? Chlorine, and alkali means what? Yes, sodium hydroxide. Understood? So here, like that, we can also this process of whatever brine solution, we call it as what? Chlor-alkali process. Understood? Now we will discuss here Okay, so we will discuss here one important thing, how your NaCl, okay, that is electrolysis of brine solution, how it will important to us. Okay, so for that we need to make one chart, one T diagram we have to make. Okay, so see here for this electrolysis of brine. See, I'm writing here electrolysis of brine. So the beta that brine is what? Yes, NaCl, NaCl aqueous. Okay, this thing you know beta. Okay, so see here how it will like that. We have to make this one T diagram for this electrolysis of brine solution. How and where we can use this, that now we are going to discuss. Okay, so as you know beta, here what? H2. So where it will occur? H2 at the cathode. At where? At the cathode. Then beta Cl2 where? At the anode. Positively charged. And whatever your NaOH here, what beta NaOH you will get? NaOH aqueous. Okay. So if you are considering uses of this, so how we can write uses? Okay. So many uses in fuels. Okay, where we can use in fuels in what? Next, margarin ammonia for fertilizers. So say margarin ammonia for what? Fertilizers. So beta basically this margarin for fertilizers means what? See here. So we have to pass bubbles of hydrogen gas. Okay. In whenever we are applying fertilizers, okay, we have to pass what? By passing bubbles of hydrogen. That is, we call it what? Margarin. Margarin ammonia for what? Fertilizers. Okay. Where okay, at that time we can use this hydrogen gas. Now say Cl2. So Cl2. Suppose if you are thinking uses here. So in where we can use, say, okay, I will write here fertilizers. Okay, so say here whatever your Cl2. So Cl2, as you know, okay, your chlorine water in water treatment, we are adding this water treatment. Okay, the next in swimming pools also we are adding, yes. In swimming pools. Okay, then your what? In the preparation of PVC, polyvinyl chloride PVC pipes. Okay, disinfectant, whatever your Cl2. Then in the preparation of CFCs, chlorofluorocarbons. Okay, and we can write what as a pesticides. Okay, so many uses of this chlorine also here. Now NaOH. So NaOH here uses we can write, okay, degreasing of metal means for cleaning of metals. Degreasing of metals, that is what? Cleaning of metals. NaOH in what? Paper industry, textile industry, then textile industry, whatever we can use NaOH. Okay, in soaps, in making soaps, then detergents. Okay, so many uses of this your NaOH. Then artificial fibers also we can make from this NaOH. So like this, whatever how NaCl is used. Okay, whatever your NaCl, whatever NaOH aqueous, that is brine solution, we can use as the raw material for various chemicals. Okay, here most important thing we discussed. Okay, now we will see how your mixture of chlorine and NaOH we can use togetherly. Whatever chlorine and NaOH is used, okay, to bleach, how we can use this? Yes beta, to bleach Okay. Then what for household bleaches? Okay. Where we can use this for household bleaches. Okay. Then to bleach fibers, to bleach fibers. Okay. So next year, say whatever your mixture of this H2 and Cl2, where we can use this. Okay, for in the manufacturing of, okay, cleaning of steel. First we will discuss here cleaning of steel in the manufacture of your NH4Cl, ammonium chloride. Okay, in medicines, in cosmetics also. Okay, so these are very much important. So whatever your NaCl, how we can use as a raw material for various chemicals. Okay, understood this thing? So much important, very important is. Now we will discuss here next thing, that is second. So first we discuss important salt, that is NaCl. Okay, so we will discuss next bleaching powder. Okay, so see here bleaching powder. So bleaching powder formula, as you know, chemical formula is what? CaOCl2. CaOCl2, bleaching powder. So how it will form with a bleaching powder? So bleaching powder is formed by the reaction of, or by the action of Cl2 gas on slag lime or what? Lime water, calcium hydroxide. Okay, understood? So see here, whatever Cl2 is we got from this electrolysis of brine solution, so that Cl2 we have to use here. Okay, so like that here, CaOH twice plus Cl2 gaseous. Okay, so what you will get? Yes, you will get after heating. You must know this heating sign. CaOCl2 plus what you will get? H2. So we will see whether our reaction is balanced or not. Ca, 1 Ca, 2 hydrogen, yes, 2 hydrogen, beta 2 oxygen, yes, 2 oxygen, and Cl2. So everything is balanced. Okay, so whatever means we can write here what? It is slag lime, and is what? Bleaching powder. Okay, now this whatever bleaching powder we can it is also called as, okay, it is also called as what? Calcium salt of hypochlorous acid. Calcium salt of hypochlorous acid, or this bleaching powder we can also it is called as chloride of lime. What beta? Chloride of lime. Understood? Okay, now we will discuss here some important properties of this bleaching powder. So say here properties. So basically this what beta? First see property. Whatever this bleaching powder, some yellowish white powder. Okay, in bathroom cleaning also we can use this, and you saw, I think. Okay, so whatever this bleaching powder, yellowish white powder. Okay, in that strong smell of chlorine, white yellowish powder. Okay, presence of what? Strong smell of chlorine. Strong smell of chlorine. So second we can write it is insoluble in water. Okay, it is insoluble in water and leaving behind a small residue of lime and leaving behind small residue of what? Small residue of lime. Also, that lime we can call what? CaO, quick lime. Okay. Now see here, we will discuss in property uh, important reactions. Okay, when bleaching powder is treated with excess of dilute acids, so what will happen? Okay, whatever your bleaching powder, when it will react with excess of dilute acid, so what you will get? Okay, so say here, whatever here this bleaching powder, CaOCl2 plus. Suppose here if you take H2SO4 dilute acid, so what you will get? Obviously you will get what? CaSO4. What you will get? Calcium sulfate. So again what you will get? Which gas here will evolve? Yes, Cl2 gas. H2O plus Cl2 gas. Okay. Now suppose if you are considering CaO, whatever your bleaching powder, when it reacts with dilute Cl. So what you will get? See, is obviously you will get what? CaCl2 plus H2O plus Cl2. Okay. So these two main important reactions here. Okay. We can balance also. Yes, our reaction is balanced. Okay. See, one more here. So bleaching powder with a physical property. Now we will discuss uses. Okay, uses of bleaching powder. Uses of what? Bleaching powder. So in uses of bleaching powder, we have to concentrate on. Okay, whatever your bleaching powder, it is mainly used what? To bleach. First we can write to bleach what beta? Textile. Okay, to bleaching cotton, and in textile industry wood and paper pulp. Okay, to bleach textile, in textile industry. Okay, in wood industry, in paper pulp. Okay, whatever paper we are preparing. Understood? Second, it is strong disinfectant and therefore it is used for sterilization of water. It is strong disinfectant. Okay, strong disinfectant. Therefore, it is used for, yes, where we can use it is for sterilization. Sterilization of what? Water. Okay, understood? In metropolitan cities, whatever this bleaching powder, so many uses. Okay, one more we can write is a strong oxidizing agent. Why it is strong oxidizing agent? Because presence of this oxygen. It is whatever your bleaching powder is strong oxidizing agent. Like that, as you know, KMnO4, whatever your potassium permanganate, is also strong oxidizing agent. So as you know, we are adding during rainy season whatever that's potassium permanganate in well. Okay, in Marathi we call it the विहिरीमध्ये आपण ते टाकतो mixture. Okay, in 15 liter of one bucket, we are adding that, dissolving, and we are pouring in that well. Okay, विहिरीमध्ये आपण टाकतो. Okay, now say it is used to whatever from this bleaching powder. Okay, fourth use of this bleaching powder. Okay, it is employed for making unshrinkable wool. Unshrinkable wool. Okay, so very much important this thing. Whatever our bleaching powder we can use to make unshrinkable wool. Okay, unshrinkable means as you know, wrinkle types it will form. So by using this bleaching powder, we can make as a unshrinkable wool. Okay, so whatever we discuss in this lecture, whatever NaCl, how NaCl we can use as a raw material for different chemicals or variety of chemicals. And next thing we will discuss second, that is bleaching powder, calcium oxychloride also we can call calcium oxychloride to this bleaching powder. Okay, I hope you understood all these things. Okay, thank you. Take care and stay safe.